Today's video is about geometric series. We've talked about geometric sequences, which is a list of numbers that has a common ratio, but a geometric series is the sum of a geometric sequence. And to find that sum, we are going to use the formula capital S sub n equals a sub 1 times 1 minus r to the n power over 1 minus r. So it looks like a lot of stuff, but it's not too bad once you remember it. N represents the number of terms. A1, as always, is the first term, and r is the common ratio. So we're just going to use this formula and jump right into finding some sums, some series. All right, we need to know, in order to use our formula, let's rewrite the formula first. Okay, so to use this formula, we want to know what n equals, we want to know what A1 equals, and we want to know what r equals. So n is just how many terms there are, and this tells us we want to know for 14 terms. So n equals 14. A1 is the first term, so A1 equals 4. And r is the common ratio, which is the second term divided by the first term, in this case 5. And now we're just going to put that all together to find a formula, and it's going to be, we're going to do S sub 14 equals A1, which is 4, times 1 minus r, which is 5, to the 14th power, n is 14, divided by 1 minus r, which is 5. And as we reduce this, we are going to get, we're actually just going to type this into our calculator as like all in one step. And it is going to give you a gigantic number. 6,103,515,624 is the sum of the first 14 numbers in this series, or in this sequence. So let's try another example. We want to find S20 of this series, or of this sequence. So we want to know what n equals. We want to know what A1 equals. And we want to know what r equals. So n is this number, 20. A1 is the first number, 81. And r is the second term divided by the first term, which is going to give us 1/3. So our formula is going to look like this. S sub 20 is equal to 81 times 1 minus 1/3 to the r, or no, that's r, to the n power, so to the 20th power, divided by 1 minus 1/3. Now, whenever you do this math, you have to make sure you do the exponent first. And you can type it in your calculator exactly like this, and it will work. So for this problem, you should get 121.5. All right, problem number 3. It says find the indicated sum for each geometric series. Well, this one's a little confusing because it gives us the end number, but it doesn't tell us what n equals. So we need to know n, we need to know a sub 1, and we need to know r. So we don't know what n is yet. A1 is 3, and r is 6 divided by 3, which is 2. What we can do is use the sequence formula to find n. And to do that, we want to use a sub n equals A1 times r to the n minus 1 power. So we know everything in this equation except for the value of n. We know that a sub n is equal to 6144. We know that a1 is 3. We know that r is 2. And we need to find n minus 1. So what we will do is divide both sides by 3. That'll give us 2048 is equal to 2 to the n minus 1 power. And what we're going to do is we're going to test out a bunch of different exponents of 2 to figure out which one will give us 2048. So for example, if I wanted to do 2 to the 9th power, that equals 512. So that's not big enough. So 2 to the 10th power, that equals 1024. 2 to the 11th power, that equals 2048. So we can rewrite 2048 as 2 to the 11th power. And that is equal to 2 to the n minus 1 power. So that means that 11 and n minus 1 have to equal each other. So n equals 12. So instead of a question mark, we now know that n is equal to 12. And now we can solve the indicated sum. So we have S sub n is equal to 3 times 1 minus 12 to the, 1 minus 2 to the 12th power over 1 minus 2. And when we type this in our calculators, we will get 12,285. Now let's do an example in summation form. We need to know the same things. We need to know what n equals, we need to know what a1 equals, and we need to know what r equals. Now, the great thing about this is that this is our sequence formula. So this is the same as a1 times r to the n minus 1 power. So n is going to equal, this is a little bit different, I guess, because n is represented as k in this. Our n represents the number of terms. So we're going to do 20 minus 6 plus 1. So n is going to equal 20 minus 6 is 14 plus 1 is 15. Then a sub 1 is going to be what we get when we plug 6 in for k. So that is going to give us 972. And you can just do that by typing it in your calculator. And then we need to know what r equals, and that's where this comes into play. R is equal to negative 3, because that is what is in the place of r. Then we are going to plug everything into our formula. S15 is equal to 972 times 1 minus parentheses negative 3 to the 15th power divided by 1 minus parentheses negative 3. And when we type all of that into our calculator, we will get 3,486,784,644. The next thing we need to talk about are infinite geometric series. So infinite series, remember, go on forever. We don't have an end for those. And this asks us to find the partial sums for each infinite series below. So in the first one, it says the sum of the first term. So S1 is just the first term. So that's going to be 1/2. Then it says to find S2, so the sum of the first two terms. So 1/2 plus 1/4 is equal to, we're going to go into decimal form, 0.75. And then S3 is the sum of the first three terms. So we're just going to continue on in that pattern. We're going to get 0.875. Then we're going to get 0.9375. And then we're going to get 0.96875. And don't worry about that down there. So this says a series that approaches a certain sum is called a convergent series. So if you look at this, the sum of this series gets really, really close to 1. So the series approaches 1. Because if you look at this, the decimal just gets bigger and bigger, but it gets close to 1 and it's never going to go over 1. Then in this other series on the right side, S1 is going to be 0.5. S2 is going to be 1.5. Then 3.5, 7.5, 15.5, and 31.5. Now this series does not have a certain sum and is called a divergent series. So let's look at the difference. It says if the absolute value of R is less than 1, then the series is convergent. If the absolute value of R is greater than 1, then the series is divergent. So convergent means it approaches a certain number, and divergent means that it doesn't have any limit. And it can go to, it'll just keep getting bigger and bigger and go to infinity. To find the sum of a convergent infinite geometric series, we will use this formula. Sn equals A1 times 1 over 1 minus R. So let's try number 9 together. The first thing we want to find is R so that we can determine if the series is convergent or divergent. And then if it's convergent, we have to find the sum. So R is always equal to the second term divided by the first term. So 1/4 divided by 1 is just 1/4. Okay, the absolute value of R, the absolute value of 1/4 is less than 1. So that means that this series is convergent. And that means we need to use our formula to find the sum. So Sn equals 1 times 1 over 1 minus 1/4. And this 1 comes from being the first term, and this is the R value. When we type this into our calculator, we will get Sn to equal 4/3. So the important parts of your answer are here, here, and here. Let's try number 10 together as well. So the first thing we do is find R. R is always the second term divided by the first term. 8/3 divided by 2/3 is equal to 4. And the absolute value of 4 is greater than 1, meaning that this series is divergent, and we do not have to find the sum of a divergent series because it's going to be infinity. It's going to get bigger and bigger forever. So that's all we do for number 10. And the last example I'm going to do with you today is one in summation notation. So notice that there is an infinity up here. That's how you know that this is an infinite series because it doesn't have any limit on the number of terms. So we are going to find R. If you remember, our formula for a geometric sequence, so the list of numbers, is A1 times R to the n minus 1. So R is 1/4. And the absolute value of 1/4 is less than 1. So that means this is a convergent series. And we need to use our formula to find the sum. So S sub n is equal to A1, which, look, A1 is -2. Actually, A1 is when you plug, A1 is when you plug this value in for the variable. And in this case, it happens to give us -2. 1 over 1 minus R, which is 1/4. And when we plug this in, we should get -8/3 as our answer. And the important parts of your answer are R, convergent, and -8/3. Thank you guys for listening and have a great day.